Take a slow breath in. And now let it go. What you just exhaled was not only carbon dioxide. It was the chemical echo of billions of mitochondria working inside you. We often say mitochondria are the power plants of the cell. But that phrase barely captures their significance. They are not just energy producers. They are metabolic decision makers, stress sensors, inflammation regulators, and perhaps most importantly, they are upstream of almost every chronic disease we face today. In the previous episodes, we explored how volatile organic compounds in your breath reflect metabolic activity. Today, we go deeper. Because if breath carries metabolic signals, then mitochondria are the source. And when mitochondria drift, breath changes first, long before symptoms ever appear. Let's step back. Nearly every modern chronic disease shares common roots: cardiovascular disease, type 2 diabetes, neurodegeneration, autoimmune conditions, accelerated aging, different organs, different symptoms, but remarkably similar biochemical beginnings: oxidative stress, chronic inflammation, metabolic inflexibility, energy production imbalance. All of these begin inside mitochondria. Not in arteries, not in the pancreas, not in the brain, in the cell's energy centers. And when energy production becomes inefficient, byproducts increase, and byproducts become volatile, and volatile molecules leave through breath. Each of your cells contains hundreds to thousands of mitochondria. Highly active cells, like heart muscle, brain neurons, and skeletal muscle, contain even more. Their primary function is oxidative phosphorylation. They convert glucose, fatty acids, and oxygen into ATP. But ATP production is not perfectly clean. Energy generation produces reactive oxygen species, ROS. In small amounts, ROS are essential signaling molecules. But when mitochondrial efficiency declines, ROS production increases disproportionately. And that is where the cascade begins. Healthy mitochondria are efficient. They maintain membrane potential, regulate electron flow, precisely balance ROS production with antioxidant defenses. But under chronic stress, poor sleep, ultra-processed diets, environmental toxins, psychological stress, sedentary behavior, mitochondria become strained. Electron transport chain inefficiency leads to electron leakage. Leaked electrons react with oxygen. More ROS are generated. Oxidative stress increases. And lipid membranes, including mitochondrial membranes, begin to suffer damage. This damage generates volatile byproducts, which means breath becomes a reflection of mitochondrial health. When mitochondrial ROS overwhelms antioxidant systems, lipid peroxidation increases. Aldehydes form. Alkanes form. Ketone patterns shift. Fat oxidation dynamics change. These compounds are volatile. They diffuse into blood. They enter alveoli. They leave through breath. Your breath is not random. It is the downstream vapor of mitochondrial chemistry. Aging is often seen as time passing. But biologically, aging is cumulative cellular stress. One major theory of aging centers on mitochondrial decline. Over decades, mitochondrial DNA accumulates mutations, electron transport efficiency decreases, ROS production rises, ATP production declines, cells become less resilient. Tissues become more inflamed. Organs lose adaptive capacity. But long before wrinkles form or memory declines, mitochondrial inefficiency begins. And that inefficiency alters metabolic byproducts, which alters breath signatures. Breath may reflect biological age more than chronological age. Metabolic flexibility is the ability to switch between glucose and fat efficiently. This switching depends heavily on mitochondrial performance. In insulin resistance, cells struggle to oxidize glucose efficiently. Fat oxidation becomes dysregulated. Mitochondrial overload occurs. ROS production rises. Breath acetone patterns shift. Aldehyde signatures increase. Years before fasting glucose becomes abnormal. This is the silent mitochondrial phase of metabolic disease. And breath may detect it early. Neurons are extremely energy dependent. Even slight mitochondrial inefficiency in the brain can alter neurotransmitter balance, increase neuroinflammation, reduce synaptic resilience before cognitive symptoms appear. Oxidative stress in neural tissue produces lipid peroxidation byproducts. Some of these volatile compounds appear in breath. Emerging research suggests breath profiling may one day assist in early neurodegenerative risk screening, not replacing imaging, but adding metabolic insight. Again, upstream of structure. Now comes the empowering side. Mitochondria are adaptable. They respond dramatically to stimulus. Regular aerobic exercise increases mitochondrial biogenesis, improves electron transport efficiency, enhances antioxidant enzyme production, reduces baseline ROS levels within weeks, mitochondrial function improves. Breath VOC patterns shift accordingly. Improved metabolic stability. Reduced oxidative markers. The body is not fixed. It is responsive. And mitochondria are central to that responsiveness. Sleep is not passive.